we have the superposition principle. What is the superposition principle? That when two or more waves combine with each other, the resultant wave will always be the sum of the two. So, example, if we have two waves, this is the first wave, and we have the second wave. And these two waves combine with each other. We want to find the resultant of these two waves. So how we can work out the resultant of the wave? So according to the superposition principle, that when two or more waves combine with each other, the resultant wave is always the algebraic sum of the two. What does it mean, the algebraic sum? Like example, say this is 1, 2, 3, 4. And here also 1, 2, 3, and 4. So for the red, at this point for a red, it's 2 meter. Example, 2 meter or 2 centimeter. And for blue, this is 4. And for blue, it is 4. So what will be the resultant wave here when we combine the resultant wave, the resultant amplitude will be the algebraic sum of the two. So it will be 2 plus 4, which will be 6. So the resultant wave, when we draw the resultant wave, say the green line is representing the resultant wave. So the resultant wave will be 6 meter or 6 centimeter in amplitude. And same way, here also it will be 6 meter or 6 centimeter in amplitude. So result of these two waves, the green line is representing the result of these two waves. And what we call this type of combination or this type of mixing of the two waves in which the crest combined with the crest and the trough combined with the trough, we call that as a constructive interference. In a constructive interference, the crest of one wave combined with the crest of another and the trough of the one wave combined with the trough of another. As a result, we have a wave which is having a higher amplitude than the two individual waves. And we call this type of combination as a constructive interference. And what is the superposition principle? Superposition principle is used to find the amplitude of the resultant wave, which is always the algebraic sum of the two. Is it clear, the concept of constructive interference? Anyone having a doubt or a question? So simply, the concept is that when two or more waves combine and we want to find the resultant amplitude of the two waves, we'll add the two amplitudes, the individual amplitudes. Say this is a axis, the y-axis, and here is representing an x-axis. So this is wave 1. And the green line is representing wave 2. And we have the marking, like example, say this is 1 and this one is 2. Same way, this one is 1 and it is representing 2. We want to find the combination of these two waves. When these two waves meet, combine with each other, what will be the resultant of these two waves? So according to superposition principle, that the resultant of the two waves is equals to algebraic sum, the amplitude of the resultant is equals to algebraic sum of the two waves. So for a wave 1, it is 1 meter, and for a wave 2, it is 2 meter. So what is the sum of 1 and 2? So when you add them, you'll get 3. So the resultant wave, like the combined wave of these two, will be 3 meter or 3 centimeter in height. And same thing, this is like 1 meter and this one is 2 meters. So what is the result? Result will be 3. So the resultant wave will be 3 meter. in depth. And when the two waves, the crest of one wave join with the crest of another, or trough of one wave join with the trough of another, what we call this type of combination, we call that as a constructive interference or constructive combination. Is it clear now? Same way, when two waves, the crest of one wave join with the trough of another, they also combine with each other, and that combination we call that as a destructive interference. Why we call a destructive interference? Because the two waves try to cancel out each other. They may cancel out completely, or maybe we may have a resultant wave, but that will be smaller in amplitude. Like this is first wave, this is wave 1, and we have wave 2. So now the crest of the one wave is joining with the trough of another. What we call this type of combination, we call that as a destructive interference. And what is the resultant wave? How we know the value of the resultant? Say this is 1 and 2, and this is 1. So here the height is say 2 centimeter or 2 meter, and here the depth is 1. So because the algebraic sum, so it will be +2 and this is -1 because it is in the negative axis. So what is the algebraic sum of a +2 and -1? So that is equals to 1. So what is the resultant wave when we combine these two together? The resultant wave will be, the blue line is representing a resultant wave. So the resultant wave will be like this. So when the two waves try to cancel out the effect of each other, or when crest of the one combined with the trough of another, what we call this type of interference, we call that as a destructive interference. So in a constructive interference, the crest of the one wave joined with the trough of the crest of one joined with the crest of another. But in a destructive, the crest of one wave joined with the trough of another. Green is not the resultant, the blue is the resultant. The green is one wave, wave 1 is green, which is the having a height of like 2 meters, the amplitude 2 meter, 2 centimeter, and the black one is representing an amplitude of -1. So when we combine these two, +2 -1, so what is the resultant? The resultant will be +1. That's the blue is the resultant wave, the result of the two. Same thing here, the black one is 1 meter and the green one is example -2 meter. So it means the resultant will be -1. That's why the resultant is -1 here. So how we get the resultant of the two waves is just adding the two numbers. If it is a positive axis, we'll use a positive number. And if it's a negative axis, we'll use a negative number. So we have the green one. This is one wave. And the blue is a second wave. And we want to find the resultant of these two waves. First, because the crest is joining with the trough, so we can identify there will be a destructive interference, means the two waves try to cancel out the effect of each other. And the positive axis, like the positive y-axis is there. So this is +1, this will be +2, and this is -1, and this is -2. Now, we want a resultant. So here, this is +1, and here this is -2. So what will the result of +1 and -2? So the result of +1 and -2 will be -1. So the resultant wave will be -1, mean negative axis. Same thing. This part is called a crest and this part is called a trough. So the crest of one wave is joining with the trough of another. That is what we call a destructive interference. In a constructive, the crest of one wave joining with the crest of another. So same way, this is a crest and this one is a trough. So crest is joining with the trough. So there will be a destructive interference. But what about the value of this destructive interference, like the resultant wave? So this is +2 and this one is -1. So what is the result of +2 and -1? That's +1. So the wave will have an amplitude of +1. Then this one, this is +1 and this one is -2. So what is the resultant of +1 and -2? That is -1. So wave will have an amplitude of -1. So the black line, the black wave is representing the resultant wave. And what we call this type of interference or a combination, we call that as a destructive interference because the two waves try to cancel out the effect of each other. So when crest join with the trough, destructive. But when crest join with the crest or the trough join with the trough, then it will be a constructive interference. Like the amplitude of the resultant wave will increase. Is it clear? So as you can see, like these two waves are combining with each other. The crest of one wave is joining with the crest of another. So if this is having an amplitude of 2, this was also having an amplitude of 2. So when they combine, the resultant will be 4. And trough of one wave joined with the trough of another. So this was amplitude -2 and -2. So the resultant amplitude will be -4 or -4. So as a result, if, for example, if this is a light wave, then we'll observe a bright light. If it is a sound, then we'll observe a loud sound. Like the interconstructive interference here refers to that the amplitude of the wave will increase or the amplitude also affects the intensity. So the intensity of the wave will also increase. But in a destructive interference, if we have a perfect destructive interference, like say this is 2 and this one is -2. So as a result, the two waves will cancel out each other. As the two waves cancel out each other, like this is a crest joining with a trough or a trough joining with a crest. So that, and they have the same amplitude, but in positive and negative axis. So they cancel out each other. This is a perfect destructive interference. So if it is a sound wave, there will be no sound. This is the same concept used in the noise cancellation headphones. How the noise cancellation headphone works, it's produce the same wave, same pattern, but in 180 out of phase. So it cancel out the noise. So this is the interference of the wave. So it is valid for light also. It is valid for sound also. All kind of waves. But the term constructive interference means then when the two waves combine, they increase the effect of each other, and destructive interference means they try to reduce the effect of each other. We may have a perfect constructive interference. We may have a perfect destructive interference. If the crest join with the crest or the trough join with the trough, perfect constructive interference. But crest join with the trough or the trough join with the crest, perfect destructive interference. So if we have wave 1 like this, and we have wave 2 like this, what kind of interference you expect? If the two waves combine with each other, what do you expect? Is it a constructive or a destructive? So there will be a constructive interference. And if these are the sound waves, we'll observe a loud sound. If these are the light waves, we'll observe a bright light in this case. What about the phase difference here? Phase difference means angle difference. What is the phase difference between the two waves? Both are starting from the same point. So when the two waves starting from the same point, the phase difference, we can say it is 0, or we can also say 2 pi. So whenever the condition is that whenever there is a constructive interference, the phase difference will be either 0 or 2 pi. Yeah, they have the same phase. So when they have the same phase, the phase difference can be referred to 0 or 2 pi. This we discussed in the beginning of the chapter, the waves, the phase difference. Like when we write the angles for the wave, we call that as a phase of the wave. So when two waves, they have a constructive interference, crest of one joined with the crest of another. In that case, we'll have a phase difference of 0, we can say, or 2 pi, which is 360 degrees. And we will have, as the two waves combine with each other, we'll observe a wave with a high amplitude. So the condition, whenever there's a constructive interference, the phase difference should be 0 or 2 pi. But when there's a destructive interference, when the two waves combine with each other, crest of one joined with the trough of another, what kind of interference we expect? Constructive or a destructive? What kind of interference here? So it will be a destructive interference. So if it's a destructive interference, what is the phase difference between the two waves? What will be the difference in the phase between the two waves? Yeah, that's good. So phase difference will be pi or 180 degrees. So whenever destructive interference happen or occur, the phase difference will be pi or 180. But if it's a constructive interference, the phase difference will be either 0 or 2 pi. Is it clear? The concept of phase difference and the destructive and constructive interference? So what actually happened when the two waves combined with each other, we call interference. If the two waves are traveling exactly in opposite direction, that type of interference result in a formation of a wave which we call standing wave or stationary wave. So what does it mean? The concept of stationary or a standing wave. Example, one wave is moving towards right and the other wave is moving towards left. They will also combine with each other. When the two waves combine with each other, the two progressive waves, the two moving waves, which are moving in opposite direction and they combine, as a result, what will happen? It will produce a wave, and what we call this wave, we call that as a standing wave. So when they form a standing wave, they produce a pattern. The phase difference can be pi by 2, 3 pi by 2 as well. But we are discussing about the perfect constructive and perfect destructive. When there's a perfect constructive, it will always be 0 and 2 pi, and perfect destructive, it will be pi or 180. But it can have other phase differences. But that in that case, some parts will be a constructive, some part will be destructive. So what is the concept of the standing wave? The concept of a standing wave is that when two moving waves, two progressive waves, moving in opposite direction and they combine, when these two waves combine, some places they increase the effect of each other and some places they decrease the effect of each other. So as a result, it produced two regions. One is called node, another one is called antinode. What is the meaning of the term node? Nodes are actually the points in the standing wave where we have a destructive interference. And antinodes are the points where we have a constructive interference. So when two waves traveling in opposite directions, some places, it's not like all, it will be a perfect constructive, perfect destructive. Some places we have complete cancellation. Some places we have the maximum amplitude. Where we have a maximum amplitude, we call antinode. And where we have a complete zero amplitude, we call that as a node. And how we represent a formation of a standing wave? So we represent the standing wave in the loops. That's how we represent a standing wave. So example, two waves which travel in opposite direction and combine and makes a standing wave. So in a standing wave, it's not like all the places there will be a perfect constructive and perfect destructive. It's like some places constructive, some places destructive. So as a result, where there's a perfect destructive, what we call those points, we call node. So this is a node, this is a node, this is also a node, this is also a node. And where we have a perfect constructive interference, what we call those points, we call them as antinodes. So this will be an antinode, this will be an antinode, this will be an antinode. So by the combination of the two waves, it produces another type of a wave, and we call that wave as a standing wave. And in this standing wave, some places there is a constructive, some places destructive. So the place where we have a constructive interference, we call that as an antinode. The place where we have a destructive interference, we call that as a node. So example, if these are the two sound waves, so this is sound one and this is sound two. So when the two sound waves, yeah, antinode, you can also write antinode here, that's fine. Antinode is just representing a position. So you can label on the top or you can label on the bottom. No, not only positive, you can label on the negative axis as well. So example, if you have two sound waves which are moving in opposite direction and the two sound waves combine with each other. So as a result, say this is a place where the two sound waves combine and you are having a microphone or a mic in your hand. So this is representing a mic. So when you use your mic, when you move your mic from one place to another, so what you will observe when you move your mic, like example here, there will be no sound. Then it will be a loud sound. Then no sound, loud sound, no sound, loud sound, and no sound. Because this place, the two waves are cancelling out each other, destructive interference. That's why you don't observe a sound. But when you place a microphone here, mic here, the two waves are increasing the effect of each other. So you will hear a loud sound. Then when you use your place a microphone here at this position, you will hear no sound. It means there's a destructive interference. Then again a loud sound. Then no sound, loud sound, and no sound. Like this type of a combination is produced. Some places it will appear louder and some places it will appear low in amplitude or no sound if it is a sound wave. Same thing if it was a light wave, then there will be, if it was a combination of the two light waves, this region, the node will be a dark, then it will be bright. Then you will have dark, bright, dark, bright, and dark. So dark here refers to like the two waves cancel out each other, and bright means the two waves increases the effect of each other. So whenever two progressive waves, moving waves move in opposite direction combine, it will give rise to a combination of a new type of wave we call a standing wave. Is it clear? The concept of the standing wave, the formation, how it is formed? Anyone having a doubt or a question in this? The formation of a standing wave? Okay. The best application of this concept of a standing wave is in a microwave oven. in a microwave oven, what you have seen, like there's a turntable. Say this is a bowl which is having a food, and why there is a table which continuously rotate or turn in a microwave. So the main reason is that we have, like example, so this is a source of a microwave. So microwave is traveling in all the directions. It is strike, like it is traveling in all the directions, and it bounce back. So as a result, what will happen? The two waves combine with each other. When the two waves combine with each other, this result in a formation of interference, constructive and destructive interference. So if there is a constructive interference, that part of a food will be hot, because the purpose of the microwave is to supply heat energy, like transfer energy. The particle will move faster. But if the combination of the two waves, like two waves combine with each other, and they try to cancel out the effect of each other, that part of a food will be cold. So even within the food, there will be regions, because of the combination of the microwaves. Some places there will be a constructive interference, and some places there will be a destructive interference. So even within the food, there will be regions which are constructive interference, and there will be regions which are having destructive interference, like cold spots. So how it can be balanced, the hot and the cold spot can be balanced. So if there was no turntable, then what will happen? Some part of the food will be hot because of the constructive interference of the waves, and some part of the food will be cold because of the destructive interference of the waves. So how it can be balanced? So that's why there is a turntable which rotate the food continuously. So as it rotate the food continuously, so even though the place where it was a constructive and destructive interference, that will have a constructive interference as well. Like because it is continuously rotating, so it will increase the chance that there might be a destructive interference in that place first. But as the food rotate on the turntable, so that part will again be in a constructive interference. So that part that will have a uniform heating. Otherwise, if there was no turntable in the microwave oven, then some parts of the food will be hot and some parts of the food will be cold because of interference of the microwaves. Is it clear? This application of a standing wave? Another standing wave, you can also produce a standing waves. You take a string or a wire or a rubber band or a string of a guitar or any string instrument. So this is representing a rubber band which is stretched between the two ends, fixed ends. When you disturb this rubber band, what pattern you observe? Like if I disturb the center, what is the pattern I will observe? I'll observe a pattern like this. Or different patterns can be observed. That's a minimum one we observe. So what is this? Actually, this is an example of, so we take a rubber band, like if you want to produce a standing wave, take a rubber band stretched between the two fixed ends, and you disturb the rubber band from the center. So when you disturb the rubber band from the center, what you will observe? You'll observe it is vibrating in this manner. What is this? This is actually a standing wave. But how this standing wave is produced? So what actually happened when you disturb the rubber band? When you disturb the rubber band, you produce the waves which strike and then bounce back. And same thing, you produce a wave which strike and bounce back. So as a result, the two waves which are traveling in opposite direction, when the two waves travel in opposite direction, they combine with each other, and some places they increase the effect of each other. The place where there's a maximum increase in effect, in like amplitude, what we call that as antinode. And the place where there's a minimum amplitude, we call that as a node. So this is the minimum pattern it produces. It can produce multiple patterns depending on the place where you disturb this string. So the standing wave, how this standing wave is produced as the two waves traveling in opposite direction, this give rise to a standing wave. Where the amplitude is maximum, that is antinode. Where the amplitude is minimum, that is node. Is it clear, the formation of this nodes and antinodes? So in a standing wave, what actually happened? The constructive and destructive interference happen together. That's why we have nodes and antinodes in the same wave. So this is a resultant wave which is forming by the combination of two waves in opposite direction. What are the characteristic of these stationary waves or the standing wave? The amplitude of a stationary wave vary with the position. Like as you can see here, when I draw the standing wave, so this is a standing wave. So amplitude vary. Like example, here we have a node. Amplitude is the distance from mean position to extreme. So here, this is the amplitude. This one is amplitude. Here, this is the maximum amplitude. So you can see the amplitude of a stationary wave vary with the position. Stationary wave is a wave which is formed by combination of two waves in opposite direction. And it will have nodes and antinodes. Stationary means it is only confined within that region. That's why we call that as a stationary wave. Stationary does not mean rest here. Stationary is a wave which does not change the place from, does not travel from one place to another. Because the two waves which are moving in opposite direction, they give a pattern like this. We call that as a stationary wave. So at the node, the amplitude is zero. As you can see, node is at the mean. And as you move, the amplitude increases and then the amplitude decreases. Eventually, again, the amplitude is zero. That's the first point. All particles between the two successive nodes have the same phase. What does it mean? Like example, this is node and this is also node. So all the particles have the same phase means if all the particles are moving down between, or all the particles are moving, all the particles if are here, they're moving up. So between the nodes, between the two successive nodes, all the particles are moving in the same direction. The particles on either side of the nodes or antinodes are 180 out of phase. What does it mean? Like example, this is one node. So this is left hand side of a node and this is the right hand side of the node. So when we show the motion of the particles, so they are 180 out of phase. What does it mean 180 out of phase? It means they are moving in opposite direction. So this is a node. Example, the particles on the left hand side of a node, if they are moving down, the particles on the right hand side of a node will move up. Or the particles on the right hand side, if they're moving down, the particles on the left hand side will move up. So the opposite side, like the either side of the node, the particles are always 180 out of phase, means they're vibrating in different direction. So if I say this is a standing wave and here is a node, so if this group of particles are going down, this group of particles are going up. Say another node is there, so this group of particle is going down, the other group of particle is going up. So either side of the node, the right and the left hand side of the node, the particles are 180 out of phase. And do not transfer energy, but their energy is like the standing wave. Why we call this is a standing or a stationary wave? That is the one characteristic that the standing wave does not transfer energy from one place to another. It just confines the energy within the region. Like if you take a string or a wire and you disturb from the center, so it will vibrate in this manner. But the energy confined within the region, it's not being transferred from one place to another. So in a stationary wave or a standing wave, the energy is not actually transferred, energy confined within the region. And all particles have the same frequency. They are vibrating in the same frequency except for the nodes because the particles are not vibrating in the node. There's a question. If a wave is moving rightward with a faster speed and the one other leftward, what will be the position of a stationary wave? The stationary wave is actually the place where the two waves combine with each other. Look, for example, this is one wave which is moving towards right, and there is another wave which is moving towards left. So the place where these two waves combine, that is the place where the stationary wave is formed. And a stationary wave does not travel from one place to another. It is confined in the region. As the two waves reach a point where they meet each other, in that place, it results in a formation of a stationary wave. So actually, stationary wave is by the combination of the two waves. But how we represent that, say the combination of these two waves, this is a stationary wave. But we represent by both crest and the trough together so that we can distinguish that this is a stationary wave which is produced. So stationary wave never travel from one place to another. It's just form in the region and then disappear. Like the moment the two objects, like example, wave 1 combined with wave 2, it produces stationary wave in this region. Once the two waves cross each other, they will follow their path. They will follow their path only. Only the region where they combine, that is the region where the standing wave or stationary wave is formed. So the speed at which the waves are traveling, that will not affect the stationary wave. Because the concept of a stationary wave is a wave which is not transferring energy. It's just formed in the region and then it disappears. That's it. And it will continuously form if the waves are continuously moving. Once the wave crosses each other, crosses the path of each other, the stationary wave will disappear. So if I say this is one wave which is 2 meters long, another wave 1 meter long,